Hi, yeah, so I'm looking at exploiting corners and finding an edge. So my story starts in 1999, in Champions League final. Manchester United are 1-0 down. I've been sent to the bath time because I'm a young boy. And I'm like wondering what's going to happen. Are Manchester United going to win this game? And I managed to have a quick bath and come back. And two amazing goals from corners. The first one, Peter Schmeichel comes up and Teddy Sheringham scores. And the second one, Solskjaer scores. And now he's the Manchester United manager. And I'm thinking, this is like a really incredible thing. And then I read recently a couple of articles that are saying corners are like really unexploited. And when you actually exploit them well, you can add goals to your overall game without actually losing anything. And then in the World Cup, it was like a perfect example where like teams really exploited corners because they haven't got much time to train in the week. But when you look at a set piece, you can really think about like how you're going to align your players, what you're going to do. So following this, I'm going to try and do a Marcello-style takedown of one team and show you how to beat them. You can look at this two ways. You can either look at it from an attacking perspective. Can we find a way to beat this team? Or you could look at it from a defending perspective. So what are we doing that could be changed? So this particular team I'm looking at is, like I said, using tracking data. So we can start to look at how they play. So I've just done a quick plot so you could just see how this team plays. It uses zonal marking. So I've taken like 11 players and just looked at the positions all over the league in the first kind of frame of a corner. And you can clearly see like up in the corners, like if there's a short corner that they put someone out there. But mostly they play a zonal marking system where in the middle they have quite a lot of players. And then, like I said, in the corners, when a short corner, they play that. And then they also have a couple of men quite deep, just in case the ball kind of falls out. So what I'm particularly looking at is like clustering. I'm thinking there's two things about corners that are really important. It's the running of players, so like how they're moving around the box. And then the second one, delivery. And I'm going to concentrate the first bit about like the kind of movement. So I'm just going to quickly explain what I've done. So actually, when you look at players moving around the box, it's very hard to like kind of cluster them together and to like combine them into one run. So what I'm trying to do is look for like similar kind of runs. I found this kind of method called TRACLUS. And what it does is it breaks up a run into different kind of portions, so like line segments. And then it tries to like group them together so that you end up with kind of like similar types of runs. I think it's like really important to use this kind of method rather than just a general clustering method, because if I've tried like doing that, and you just end up with massive blobs of things that come together, and it just doesn't tell you anything interesting at all. So what does it actually look like? This is like what it looks like for corners. You get a lot of like kind of runs, like diagonal runs, and then the end I've just like plotted where they actually end up doing. But that's not very interesting. Can't really pick out what's going on at all. And then for crossed free kicks, it's even like more kind of worse, like what's going on. Like there's a lot of like kind of runs like this, and obviously like with the kind of free kicks, usually it's around, the ball's around here, and like there's a wall, and then like the ball ends up kind of around here, so like they just kind of cross there. But what was more interesting was when I started to look at like just the runs that ended in shots. So like for this particular team, the shots actually, if you look, they end up in similar areas. So these are the players that are running to take the shot, and like there's obviously like a problem in this area. So the team has like the people are running into this area and they're managing to shoot. And then similarly around the penalty spot, like little like sort of movements around the penalty spot are causing problems for this team. And then if you look at like in this corner, I've got the similar kind of areas, but the runs that didn't result in shots. And yeah, like they're running into this thing, but they're kind of deeper runs. And then similarly for the ones around the penalty spot. So So there are different types of runs, but these ones are ending in shots, and these ones aren't. So I'm just going to show you a quick example of what that looks like in practice. So I've marked the player that ends up with a shot from the tracking data, and that's where the Opta shot is taken. And these are like the passes from the Opta data. So yeah, they do a short pass, and then that's where the player comes in. So, and then he's celebrating the goal. So I'll just show it again. So what's important is like these guys doing a little run there. I guess what's missing from this is like what the other player is doing. So there's this guy is doing the run, but actually the damage is caused by this player that like moves these two away. So, and then he just comes into the gap. So it wasn't, at the moment, I just looked at the actual, the player taking the shot movement. But I think like actually what would be really valuable is to look at the other player like that is making the space for that player. So start to look at like whether you can combine two kind of runs together and say that this guy's creating space and this guy's moving into that space. So I think the same approach could be applied, but like actually try and link two runs. Yeah, and then this is another example. I showed he's going to move into this position, the player who gets the ball. And that spot seems to be like the weakness that I showed in the kind of top right. So yeah, the two kind of areas with the guy moving around this kind of area and the guy here seems to be a really weakness for this team, and it's kind of exposed quite well by this kind of method that you take players' runs. And then I said the second thing was about delivery that I wanted to talk about. So I think two important things, running and deliveries. And I think it's good to have like at least one bar chart in a presentation. So this one's saying like the number of events into a shot. So I've taken all the Opta data from the corner being taken. This one's the first one, second, third, fourth. And obviously the second event is kind of important. So like it could be that the pass is into somebody, they have an aerial duel, and then it falls to another player. So it's like your instant thing is like, let's just whip it into the box and like have a shot. But actually no, like maybe it's the second, third, fourth thing that's important. So if we look at this kind of team, these are all the kind of areas where they didn't have shots, no shot. And the blue is where they had shots. And then there's that area there where they had problems. And this is like some example like where I've plotted where they seem to have problems with these deliveries. The second lot is the ones in the corners. Okay, these are actually the kind of wasteful opportunities. So like where the players, where the ball is like whipped quite deep or like across the box. So like when you're thinking about the attacking, this zonal-based system is not particularly good if you just like whip it straight across the box and trying to score. Okay, so actually the biggest issue that these teams have is when there's a position here where there's lots of players around, and it goes in the middle of a group of players. So I've like tried to plot this as using the vulnerabilities. What's interesting is where a player puts the ball into a position where there's lots of players from the opposition team around, they don't know which player to send to the ball. So they have a particular problem with that. Yeah, so I think I've exposed like two weaknesses in this particular team. Bearing in mind I have quite small data, I only have like one season of data. And I think they have a particular problem with the running into the corner positions and around the kind of penalty spot. And done that through this kind of clustering-based system, and also shown with the Venori diagram some particular areas where they also have issues. So I just want to take a moment to say some things that I tried, because the data science is always an interesting thing where you try lots of things and they fail. So I want to take a bit of time to talk about that. So I thought this particular type of clustering would be really useful for ball trajectories as well. So like, do they have like similar kind of balls into the box? Can you like group them and then start to say that this type of cross is causing us problems? But actually the data that I had didn't have that kind of ball level data. The actual ball went missing in the tracking in the middle of the air, so I couldn't do that. And the second thing I tried was relating to the first presentation on embedding. So I think that's a really interesting approach. And I've tried that myself, and unfortunately I didn't have enough data. But I think the embeddings approaches are like really useful. And I think if you added into that kind of team embedding and tried to capture the kind of team effects, you might then start to be able to tease out, like, actually, if you took that player out of the team, how would they play with that? And then a couple of things that I thought were really valuable for me is there's a dataset format called Feather that allows you to quickly load datasets into RAM, and you can load like all the season of tracking data in a couple of seconds. So I found that really useful. And the other thing that I want to mention is there's an algorithm called Raymer-Douglas-Poika algorithm that if you look at a ball in the tracking data, there's like 90,000 movements. It's really hard to pick out what's going to happen. But if you use this algorithm, you can take it down to like 600 different points in the match where the ball changes trajectory. And I thought that was like really useful for this kind of work. Yeah, thank you.